So in this video, we're going to briefly cover movement, up, down, left, right movement, like in a top-down game. Okay, so I've made a new scene by clicking the new scene button, and then I'm going to add a sprite. And for now, we're just going to use the Godot icon as its texture, and we're going to call this player, so we know that this is the user controlled player, and we're going to hit save, and we're going to add a script. Alright, so in this script we have a couple of things we need to do. We need to decide how fast this is going to move, so we'll make a variable to hold that number. I'm going to start with 150, and you can change that and see how you like it once you see how fast it goes. And then we need to check which keys are getting pressed. So in process, remember process is the function, the code that runs every frame. So we want to not be moving if we're not pressing the keys, and then we want to move when we press the keys. So that way if we hold the key down, we'll keep moving, but if we let go, we'll stop. So we're going to make a variable called velocity. Now velocity is the difference between velocity and speed. Velocity is how fast you're going and what direction, right? It's like an arrow. So that arrow has a length of 0 right now. We're not moving at all. But if we press a key, and we do that by checking input and is action pressed UI right. So right now UI right is the name that refers to the right arrow key input, and that's what we want to use. So if that happens, we're going to set the velocity.x, we're going to add 1 to it. Well, 0 plus 1 is 1, so adding +1 to x means going to the right. And we'll add the other keys in a minute, but let's go ahead and check it out. So we want to change the sprite's position by adding the velocity, which is going to be 1 right now, times the speed, so that we'll get it as fast as we want to go, times delta, which is the number that keeps things scaled to 1 frame, right? 1 frame is 1/60th of a second, so we only want to move 1/60th of our distance each frame. And if we run this scene to test it out, we'll see that when I hold down the right arrow key, my sprite is moving to the right. And now all we need to do is add the other keys, and I can copy and paste to do that because there's just 3 more of the same thing. There's UI left, which will be velocity.x minus 1, right? Left and right are opposite. And then there's up and there's down. And up and down, those refer to the y direction. So we got to change these to y's. And the up is minus and the down is plus. And now if we go in and move, we can move in all directions. Except now there's one catch. Let's see if I can show you. I'm gonna hold down the left arrow key, and then while holding it down, I'm gonna press the down arrow key and see if you can spot what's happening. Okay, so I'm moving to the left. Now I press down. So you can see I went diagonally, right? But when we go diagonally, we're going a lot faster than when we go horizontally or vertically. And that's because if you add +1 this way and +1 this way, your diagonal is going to be long. It's like a triangle, right? And if you've ever heard of Pythagoras' theorem, right, a squared plus b squared equals c squared, it basically just means you go faster diagonally. The diagonal of the triangle is longer than the sides, and we don't want that. So we need to say dot normalized. Normalized is a function that scales the velocity so that it's the same in all directions, and that will make the diagonals be the same speed. See, I'm going the same speed diagonally as I'm going horizontally. And now we have our directional movement. Okay, try that out and see if you can make it work. You can change the speed to make it go faster, and we will then build on that for the next step of our game.